Hey, Advanced Global Systems. So I was debating whether or not to create this vodcast to help you through the analysis of your lab work, whether or not you would be better served by struggling with it first before we discussed it in class. But I decided that I didn't want you guys spending hours and hours on it if you were missing some key parts. So what I encourage you to do is try to figure out how you develop an ED50 from your data. First, so pause now if you haven't tried that at least, and then use this to supplement after giving it a good amount of thought and effort. Because I think each of you could figure it out. There are some conceptual realizations you have to make and how to manipulate the data so it's useful to create an ED50, as I'll discuss now. So this is sample data that you could have collected. So you see I have CO2 concentration here, I have pH here, and over time, if we're plotted together, it might look like this. Here I just put arrows for when you're adding solutions. And so this is something that you all should have already. What you probably don't have is anything that looks like this. And so if you see here, I have rate of production of CO2 gas here and pH here, vinegar, bleach, and then each of those volumes. And so what's really valuable about this is the rate of production of CO2 gas. So you notice that's not CO2 concentration, right? You measured CO2 concentration. That was your dependent variable. But of course that variable, the dependent variable, was really a proxy for understanding how those organisms were doing, right? So the rate of CO2 production is a proxy for their metabolic processes, cellular respiration rate, and thus their health. And so if that rate of CO2 production goes down, then you know that the yeast is being inhibited in that metabolic process. Now you got to remember that in those echo chambers, the concentration will always go up unless you let gas out, right? So even if the rate of production slows, the concentration will increase. So you can't use just raw concentration to figure this out, and that's the trick. You need to convert to rate of production for every unit of time. Now, the iPads, the SparkView programs that you were using can do this for you, but you'd have to do it. It's also fairly easy to do on your own. I think you should be able to figure out how to convert your rate of CO2 production, so I'm not going to spend time now going into it. But once you have that, you should graph it like this, and at least hypothetically, the rate of production will go down for both your vinegar and your bleach. So over time it's going down, and here you have your dose plotted. This is a little fictitious because you don't have a continuum of dose. You have points of dose, but the x-axis is still very useful. And so what you want to do is the highest rate of production here, at least as I've graphed it, is right 72, 74, 76. So half of 76 is 38. So that's 50% of our rate of production. This is half of, let's say, each of the entire yeast population has been inhibited in its production. So the effective dose for inhibiting 50% of the population matches up right here at this 38 parts per million per second, right, of CO2. So if I go to 38, I slide out over to my graph, it matches up right there. I go down, and there I have my effective dose 50 right about here. So in between your 20 and 30 dose, that appears to be your effective dose 50. So that's in large part what I'm asking you to do. I hope that helps.